Okay, good day everyone. Okay, so in this video there will be another example problem for the topic strain. Okay, so this is still in the subject mechanics of deformable bodies or strength of materials. So let us try this problem. 2.46. A timber column 8-inch by 8-inch in cross-section is reinforced on all four sides by steel plates. So each plate being 8-inch wide and 3-inch thick. So determine the smallest value of T for which the column can support an axial load of 300 kips if the working stresses are 1,200 psi for timber and 20 ksi for steel. The moduli of elasticity are 1.5 times 10 to the 6 psi for timber and 29 times 10 to the 6 psi for steel. Okay? So this is our example problem. So in this PDF book, it has no figure available. So we make our own figure. Okay, so without further ado, we'll go to the solution. So here is my solution for this problem. Okay, so it is a composite column in which is composed of timber and steel plates. So this steel plates is surrounding this timber column. Okay, so so that's why it became composite. Okay, so the axial load to be supported is 300 kips or 300 pounds if converted into pounds. So the given are that the working stress for timber is 1,200 psi. For steel, the working stress is 20 ksi or 20,000 psi. The moduli of elasticity are 1.5 times 10 to the 6 psi for timber and 29 times 10 to the 6 psi for steel. Okay, so the first solution we can draw is that it should be that the timber and the steel will carry together the load 300 kips, which means that a portion of this 300 kips will be carried by timber alone, and portion of that 300 kips will be carried by steel alone. So it is equal to 300,000 pounds. So I converted it first into pounds. Okay, so the next one is, since there are given working stress for timber and steel, so we'll try to solve the possible value of P timber and P steel using the working stresses. But mind you that this working stress, the P timber and P steel that we can compute is the maximum safe value of them. So not necessarily the actual answer. Okay, so we will check if both of them are compatible with the deformation. Okay, so first the timber. So the stress of timber is equal to P over A of timber. So the area is 8 squared. So we get the P timber as 76,800 pounds. So this is the maximum safe load for timber, 76.8 kips. So the steel is P steel over A steel is equal to 20,000 psi. Okay, so we get this 76,800 pounds maximum safe load for timber. So the P timber actual might be less than or equal to this. So for the steel, same methodology, we equate it to P steel over A steel, or the P over A of the steel. So it is equivalent to 20,000 psi, which is the working stress of steel here. So we computed, okay, so since there is a hollow in between which is occupied by timber, so the area is 8 plus 2t minus 8 squared. So this 8 squared is the area of timber, while 8 plus 2t is the outside dimension of the steel plate. Okay, so that is the P steel. So we can get the equation. So P steel, therefore, okay, to make the long story short, is equal to 20,000 multiplied by 32T plus 4T squared. So this is the maximum safe load for steel. Okay, mind you that this computed P steel and P timber like this are the maximum possible safe loads and not necessarily the final answer. Okay, so here, since they are a composite, okay, so here, since this is a composite column, it should be that the stress, the deformation of steel should be equal to the deformation of timber. Yan. Okay? That is the main assumption, in which that under this 300 pound vertical load, vertically downward load, or the axial load, under this the deformation of steel and timber should be equal. Okay, so this is the general equation for deformation is PL over AE. So the steel and the timber has a different properties in terms of area and in terms of length and E. So we use the A and E respectively for steel and timber. So this is the area for A in, okay, so since T is not given, so it will remain as 8 plus 2T squared minus 8 squared times 29 times 10 to the 6. For timber, 8 squared multiplied by 1.5 times 10 to the 6. So when P, okay, so we assume that if that the timber will reach maximum. So if timber will be the one to reach maximum, so let's test if steel will not exceed the its maximum value. So it's just an assumption. Okay, so we here we assume first that timber will first reach its maximum capacity before the steel. Okay, so we try. So by computation, we get that the P steel, okay, so here the L is not given, so we take it that the length of the steel and timber are the same. So PL over AE is equal to PL over AE for timber. So the P timber, as we previously computed, is 76.8 kips, and this is for steel. Okay, so we substitute the timber first. Okay, 76,800. So from this, by through cross multiplication, we have computed that the P steel is 23,200 multiplied by 32T plus 4T squared. So therefore, our assumption that timber will reach maximum first before steel is false. Therefore, if P timber reaches maximum, the steel has already exceeded the maximum safe load. So therefore, it is not a possible scenario. So therefore, choose P steel to be the smaller one. Okay, from the previous answer, previous computation in stress, we get that the maximum safe load for steel is 20,000 times 32T plus 40 squared. So we use it instead of this, because in the assumption that the timber reaches the maximum first is proven to be false, because it already exceeded the maximum capacity for steel. So we use the P steel as 20,000 times 32T plus 40 squared as computed in the previously. So when the P steel reaches 20,000 times 32T plus 40 squared, so we get this one. So we substitute. Okay, so same PL over AA of steel and PL over AE for timber. So to make the discussion short, so the P timber is computed to be 66,206.8976 pounds or 66.20 kips. Okay, so this is the actual P timber. Okay, so as you can see, the P timber first we computed using the allowable maximum stress for timber is 76.8. Here, 66.207. So we choose the smaller one. So therefore, we set P timber as 66.207 kips or 66,206.897 pounds. So we back substitute to the first equation, which is P timber plus P steel equals 300,000. So we get the value of P steel. So the P steel is 233,793.103 pounds or 233.793 kips. Okay. So from that, so we get the actual value of P timber and P steel. So from that, okay, so from that equation, we will get the value of P steel. Okay, so therefore we have the value of P steel is equal to 20,000 times 32T plus 40 squared equals 233,793.103. Okay, so as we computed previously here, so we substitute to the maximum safe load of P steel, which is proven to be that the steel will reach its maximum first. So by computation or by using sheep solve in the calculator or by performing a quadratic equation for a quadratic formula, so we get 0.35 inch. Okay, so let's review. So these are the solution. Okay, so these are the solution of this problem. So this is the recap. Okay, so thank you for listening.